Okay. Um, do you want to um
Yeah, I
say
can I
something?
can go next. So, hey guys, I'm Yihua. So I'm currently the one of the main contributors to this production stack. Also, I'm the one of the main contributors to the Mcache project, which helps doing the KV cache offloading from vLLM, and also this is right now used in production stack. Should we just go through this attendees list?
Yeah, maybe we can it's better if we can go through the attendee list. Yeah, Eve, do you want to do a brief introduction?
Sure. I'm Yu Calico. I work at Lambda. I'm a senior staff engineer and I'm lead tech for our Kubernetes product, which we're running our inference stack on top of. So vLLM has been a big part of that.
Nice. Okay. And uh James?
Yep. Hi, I'm James Westbrook. I'm a senior DevOps engineer at T-Mobile and the Helm charts maintainer for Open Web UI. I've used vLLM for a lot of personal open source stuff and have done some looking at it at work and stuff like that. But we're starting to look at doing a lot more inference than we ever have. So excited to contribute to this product and make it easier to run vLLM at scale.
Yeah, thanks, James. And Xiaoting.
Hi, I'm Shaoting. I'm a student at University of Chicago, and I'm one of the members of the production stack team.
Oh, I'll go next. My name is Hanchen. I just graduated from U Chicago. I'm currently working on making the production stack like workable in Racerf as well. So yeah, shoot me a message if you want to talk about this. And yeah, I also work on deploying production stack to more cloud service providers. And yeah, we can also talk about that if you want, chat. So.
Okay, Paul is can talk now, but like, yeah, we can skip him for now. Yeah, so the agenda for today is like we can go through some discussion items like written by people like beforehand, and we can have some discussion on like how to on the for example like some features like we want to have in production stack and what contributors think of like the features and how to design the interface for the features. Yeah, so okay. So to start with, like one thing that has been brought up by many contributors and in the issues or Slack space is like how can we support like multi-node inference for VLM? And right now, like we don't have that much expertise for to doing so. So like this is something we want to call for help. And yeah, if anyone is interested in it, like feel free to bring up some designs and we can work together to write a proposal. Um, yeah, and yeah, and also like if you want to take the lead of this functionality, feel free to do so, and we can promote you as a maintainer for this functionality. Yeah. Okay. Yeah. Um, does anyone like has any like idea of how to design the interface or how to support this in production stack?
I have experience running multi-node inside of Kubernetes for inference. That's one of the main things that we were doing for a while. We're running R1 not long after it came out on 16x H100s, pairs of 8x machines. You're going to need a high-speed interconnect, of course, if you want to do multi-node for a single model. And I know the EP parallel and the DP parallel are coming out soon or getting worked on. So there's a couple of approaches for doing that inside of Kubernetes. We don't have to necessarily dig into all the details here, but fundamentally, you just have to make sure that you can either use built-in Kubernetes objects that can understand where, for example, the concept of a head node and worker nodes is roughly what we're replicating, except for you're doing it with like a head pod and worker pods. And so, similar to how you do multi-node PyTorch training, you can do it through bare Kubernetes objects such as stateful sets, which or even index jobs. Some mechanisms so that you can identify the first one programmatically. You don't have to have hard-coded values. And you can also do it with custom operators. PyTorch has a good number of examples of custom operators that, or the ecosystem, I should say. It's not PyTorch itself. So, for example, Kubeflow has an operator that can understand a bunch of CRDs, custom resource definitions that define different types of jobs, including PyTorch jobs. And when you define that, you can specify that you want it has like a dual pod spec, essentially. So you have like workers and then you have the master. And so it will automatically set up pod environment variables for the different workers so that they know how to talk to the master one. Same thing is true with other scheduler systems like Volcano. So I see it as essentially either you stuff this into stateful sets and make use of the functionality they have there, or index jobs. Index jobs are a little worse at this than stateful sets. Or you leverage an existing operator, maybe modify one, maybe build a simple one. They're not terribly difficult to build if you stick with a simple one.
Yeah, that's really helpful. Yeah. Just curious, like, are you is it okay if we can work together to design the interface for multi-node support in production stack, like together? Yeah, if it's okay, we can. Yeah.
Yeah,
Okay.
just you can ping me in the Slack. I'm happy to talk about it. I literally do this for a living all day, every day. So yeah, ping me.
That's really nice to know. Okay.
Eve, I'm just curious too. Have you ever looked at lead worker set? Because that's one of the things in the vLLM docs that they explicitly call out. That's kind of the route that I was going to start going down, but I do not have as much hands-on experience with it yet.
Yeah, so I saw the SIG from Kubernetes, and I looked at their design doc and roughly how it's implemented. I don't have a lot of hands-on with it yet, unfortunately. I want to. I saw it as well in the BLM doc, and I thought, oh, that's interesting. I wonder how far along they are in leveraging that. It sounds like maybe not. Maybe it's just kind of like that's the idea for a direction to go at this point, which it very much could be. It might be a great solution because it it's a mostly a superset of the same functionality that you would hope to get out of stateful sets or index jobs, but with the idea of being a new kind of construct, but it's built into Kubernetes instead of being a custom operator that explicitly is designed to make sure that you can run things that require a lead worker of a set and that they can talk to each other. Hence the name, right? So it sounds like it's a perfect fit, and it might very well be, but I just don't personally know. Yeah, I haven't looked at it that deeply.
Cool. Yeah, there's an issue somewhere. I forget if I think there's an issue on production stack and there's an issue on vLLM, like on the GitHub issues about the need to support Ray out of the box on Dockerfile, or else you have to like build your own Dockerfile. Somebody had like PR'd a script into vLLM to help with that, but I don't think it made it into the Dockerfile yet. And I meant to open a PR for that, but have not got a chance to test that and make sure that it works, because I think that was like the current blocker to trying lead worker set without having to build your own custom image for it.
Mhm.
But I think that was the direction I was going to try to go.
Have somebody mentioned, I forgot who, I apologize, you're working on the Ray serve part of the LLM?
Yeah,
Uh,
but yeah, I'm more working towards just like running like it's not like multi-node inference, it's more like just r routing it. Let's say if the KV cache is like in node number one, just route it there. But this is definitely like the next step if we are using Ray because it has this native support and we should be doing this. But yeah, I'll be looking into that once we have like a Ray version of production stack on like, single node inference. And
okay. Well, the reason I ask is because I did actually spend some time about a weekend ago writing a new updated entry point wrapper for VLM and Ray, Ray serve specifically. because I
Mm-hmm.
saw that there was an example one on the Ray project website, but it
Mm-hmm.
was for a much older version.
Oh,
And it
was it like
also,
Ray like
yeah, it was designed for vLLM like v6.2 or 6.1 or something like that. They didn't quite get it. And also they copied some of the API server entry point code into the actual Ray wrapper instead of just like consuming the upstream code from vLLM.
I see, I see.
Yeah.
Mm,
So I
okay.
actually wrote my own wrapper that was compatible with 73073 and actually uses the all of the upstream entry point code and calls it and folds it into the wrapper instead of copy pasting it so that it can support all of the command line flags and all that stuff. I shared it in the Slack like a week ago with somebody who was looking for that, but I can
I
re-link
I
it.
I see. That would be very helpful. Like, by the way, could I ask, like, what the was the old repo that you saw like RayRM, or like was it named like by another name? I'm just curious.
No,
Like
no, it's
the
under
old one.
it's under the main Ray docs. So if you go to
Okay.
docs Ray IO latest serve tutorials vLLM example,
Oh, okay.
um, yeah, they have the
Yeah, I got you.
example there, and it's if you look through it, you'll see that they've copied like the OpenAI serving chat and the V1 chat completions route, and they're re-implementing some of those pieces inside of their wrapper instead of like using the upstream API router and the upstream entry point functions
I
to
see.
do the init engine state and the build app and stuff. So I wrote a wrapper that actually just calls those, but you have to do fast API lifetime management
Yeah,
and a
yeah.
bunch of other stuff. And so I spent like a weekend figuring out how to do that so that I could
I
run
definitely.
RayServe. Yeah,
That's awesome. That's awesome. Yeah, I would very much like to talk about this. So like maybe we should bring it offline for this.
sure. Yep.
Yeah. Wait, by the way, are you in the Slack channel?
Yeah, I'm in the Slack.
Oh, yeah. I'll just send you a private message about it. Thanks.
Cool.
Cool, cool, cool. Yeah, so yeah, it will be great if like we can open an issue on GitHub, and so like we can discuss more detail there, or like bring it offline to design the interface for multi-node support. Yeah, okay. So the next item is like discuss differences between production stack and the new AI bricks released like last Friday. So yeah, like at a high level, like production stack and AI bricks has pretty different philosophies. And so one thing is like production stack is more open to like letting the whole community to design sorry one sec. There is like a meeting summary. Sorry, let me check. Okay. Yeah, sorry. So one thing like for production stack is we want the community to design interface together. And like another thing is like the production stack is all written in Python. And if developers want to change any serving logic, they just need to write in Python. And another thing is like production stack is always like keeping up with the newest vLLM version because we have a upstream on cache connector in vLLM. And but like AI bricks as we checked, like its KV cache interface is only written in a very outdated version like 0.6.1. And we actually did some preliminary we did preliminary benchmarks over the last few days, and we have seen that like production stack has much better like performance compared to AI bricks when we use AI bricks CPU offloading.
By
And
the way, you're not sharing the screen with the performance benchmark. Is that intended, or?
yeah, like Yuhua, can
I
you?
can quickly paste the
Yeah,
image to the Google Doc. I just got this afternoon, but we're trying to run some simple benchmark on the using the production stack versus AI bricks versus very basic and native Kubernetes deployment of vLLM. And let me try to paste the figure here. Oh, it's too big. Yeah, but the thing is, maybe can you scroll to the next page? So the thing is, what we're observing is that if we're trying to also enable the KV cache offloading functionality in AI bricks, is the performance is actually being even worse than the native Kubernetes deployment. And I think we already released the benchmark script for this to reproduce this figure, and we will working on releasing a new tutorial to for everyone to reproduce this result in the production stack repo.
Oh, so we run this with my Llama 8 billion model. And we we only use a single node to test performance.
Yeah, this is like I said, this is a pretty simplified setup, and we're just trying to get some quick numbers, and we will make the benchmark more comprehensive in the coming days. Yeah, just feel free if you want to, like, we can actually open a issue or something, but and just feel free to leave your thoughts there about, like, say, what kind of workloads and what kind of setups we want to try.
Just want to confirm we are going to raise an issue discussing this in production stack, right?
Yeah. Let's raise that issue.
Cool.
Oh, inference benchmarker. Cool. Thanks, Ed. Yeah.
Yeah, and I also heard that there's a Gen AI Perf tool, open source from NVIDIA, that might also be useful.
I have a quick question about so you're testing on a single node, and we can discuss more in the issue when you make it, but I'm just curious, are the folks who are working on this particular portion, do you have access to more machines?
Yeah, we have access to more machines, and
Yeah, right now we are trying to run some GPU machines on Lambda. So
Okay. Well, because I was going to say, like, I mean, I don't know about an official sort of reaching out to offer machines. We might be able to do that too. I can't make that decision myself, but I have access to free machines. I use them for developing the stuff we're doing on our inference stack. And so if you need a benchmark run on a thing, I literally have dozens, if not hundreds, that I'm always using for testing and running stuff. So
We've been paying a lot of money to Lambda Labs in recent months
okay.
already, so that would be great.
Lambda is easy to use.
yeah.
Cool. This will be very helpful. We can talk about this offline. I think
Yeah,
it will be very,
sure.
very, very useful.
Yeah, I mean, I can't spin up hundreds for free and let them run for months, but if you need a machine with a bunch of GPUs on it for a test, it's very easy for me to do. So, or
Great.
if you need a test run and I already have stuff running, I can just throw it on there. It's not a big deal.
Great. That's really useful.
Thanks.
Thanks. Okay. Yeah, so another issue, Yihua, like unify. Yeah, there is a issue on GitHub just brought up today. Like they are saying like we can have unified naming for different components, for router, for Helm chart, and for container images. Yeah, just want to raise a discussion here, like to hear like your thoughts on this.
Yeah, maybe can you help, like, click the link? I can explain it a little bit. So the problem is that currently we have multiple components, including this Helm chart, including the request router container, also including this Python package name we right now we call it VM router. So the naming is a little bit confusing here as setting the issue. So we are trying to come up with some better naming convention for all of those components. So I'm trying to bring it up here. So if anyone here have any ideas, just feel free to share in this issue, and we can like make this naming more clear and more understandable. Yeah, that's
You want it more consistent, right?
yeah,
So
yeah, yeah, more consistent.
how about you come up with some candidates and let the community vote?
Yeah, that's actually a good idea.
Yeah.
That's like a good. Maybe let's do this in Slack channel or something. I can.
Yeah, with GitHub issues is always the easiest way, and
Okay,
then
GitHub issue is also okay. Yeah, I can draft something here, and everyone can react
just
on it.
ask people to sum up, sum down, or choose one, two, three. Like,
Yeah. Yeah. Cool. I can try to draft a few proposals. Yeah, but feel free to leave your thoughts here.
Yeah, and
Maybe hopefully not too much of a sidetrack, but is the plan to leave the router in production stack repo forever, or are you considering moving that out into a separate repo?
Oh, that's a good question. I think right now we don't have any plan to move it to another repo. So basically
Yeah.
it will be
yeah,
still
but
here.
we do want people to use the router isolate, like without involving the whole stack. We do want to provide user a way to do that. Yeah, but we won't make it leave the platform.
Yeah, and I think we are also trying to uh include more optimizations, move more optimizations around the vLLM stack, basically around the vLLM. Those optimizations around the vLLM should be like go to this repo, and we are trying to maintain those optimizations. That's a long-term plan. Yeah.
Okay. If I just lose track of the real quick. Okay. So on my side, I want to do a quick update on the prefix cache aware routing. So basically, the prototyping is already done, and I already got some benchmarking results. I can share it inside the issue, and I'll raise a PR shortly. But several design decisions are, first, we use string instead of token IDs to do routing. Token ID is accurate, of course, but tokenizing is slow. So basically, tokenizing will introduce several milliseconds overhead for every request, which is not very acceptable. And we introduced two algorithms to do prefix cache aware routing. One is like doing longest prefix matching using a hash-based try, and another approach is to use a same hash, use a hash ring based algorithm using same hash. And currently, thanks to the super fast hashing algorithm, the hash try based approach is faster, but hash try needs to maintain a hash try, so it has internal states, which means that we cannot, like, at least it's not optimal to scale the hash try based router by simply replicating. We need to synchronize their internal states. But for the hash ring based approach, it can easily scale because it's stateless. Yeah, and I'm writing an actual PR to make it land. So basically, I'm introducing two new abstractions so that people can contribute more in the future. The first abstraction is to do load balancing by masking out overloaded nodes. And the second abstraction is the request endpoint matcher, basically doing the matching between request and endpoint. Yeah, and I guess that's all for the current prefix aware routing. Yeah, and this will be one of the major feature that is mainly for LLM sake. So it's a non-traditional feature, and so we do want to make it land faster. Yeah.
could you explain more about the use case of this behind this? Request the endpoint matcher?
Yeah, so basically request endpoint matcher is basically trying to find the best server for this request. For example, has the longest shared prefix, or maybe in the future we can do a more sophisticated, maybe like hierarchical, maybe like priority-based routing. But the functionality of that is basically trying to find the best server that fits that matches with this request best. And
You
for
mean the content, the input content of the request, right?
the input content, and also maybe the inputs metadata. For example, maybe for
I
some,
see.
we can see that it's online or offline in the future, and maybe we can deprioritize the offline request in the router. But yeah, here we want to
Do you have a like structure or already fixed the structure for metadata and like predefined fields for those metadata, or this is open for discussion?
So currently, currently implemented request endpoint matcher, existing ones won't touch any fields outside the OpenAI API.
I see. I
This is
see.
API's field, but in the future, yes, we can augment it with more fields, but the field's name then is open for discussion.
Okay, thank you.
I have a quick question. For your load balancer logic, you say mask out overloaded nodes. How are you detecting or determining overloaded?
Basically, we are going to provide several ways. So the way I'm currently using is by detecting the number of queuing requests. So by
Mhm.
queuing, basically the requests that are entering the engine but not being executed.
Right.
That indicates the inference engine is already fully utilizing its GPU space. So it's a sign of at least it start to buffer. So it's a sign of like showing that it's already kind of overloaded.
Okay.
I think after this PR is in, there will be an interface for people to easily customize their own logic in the router.
Yeah, and
Yeah, that's also my question. And how will you design this interface? So what kind of information you are going to make it available? Because like in Kubernetes, what they are doing is they allow you to do the filter and score. And then they are doing it like plugin, filter and score plugin. So people just need to write scoring functions or filter functions, and everything else is just taking information from observability. Will you have something similar?
the API will be
Is that something you want to open for discussion?
I will send a PR out and then we can discuss, but the API currently is pretty like it's a slightly different than in existing Kubernetes because there's prefix. So prefix we need to maintain some internal state for the router. So there needs to be some explicit APIs to not only filter the servers but also allow the
Matching the prefix. Understand. Interesting. Okay. If you have the description or issues, could you put it here, and so we can take a look.
Okay, sure. Yeah, I will I'll like raise a PR through GitHub and then we can discuss. Yeah. Okay. And when like another item is that when I'm doing this, when I'm implementing this router, I found that this kind of like prefix-based, like this is kind of like prefix-aware router. There is a okay. So yeah. Okay, so I'll like since the time is approaching, let's be quick. Yeah. Basically for the prefix cache aware, like for the prefix cache aware router, it will easily overload one node. For example, if all requests share the same prefix, it will route every request to that node and it will quickly overload that node. And to solve that issue, basically, I'm thinking of several potential solutions to do that. And one of them is to simply duplicate the request. And so basically, we will duplicate those requests with very hot prefix to other machines so that we can like avoid overloading the node with the hottest KV cache. Yeah. And also I'm looking into disaggregate prefitting support. So basically for disaggregate prefitting, the current state is that vLLM itself is not ready. And I'm like shuffling the PRs there to make sure vLLM is ready first. And then we can circle back to production stack and to provide more routing support.
Okay. Yeah, thank you everyone for the great discussion today. Yeah, since people are already dropping, like we can continue the discussion next time. Yeah. And by the way, like for people who are interested in benchmarking in AI bricks and production stack, feel free to run our like open source benchmark code to try to reproduce or run more like different workloads to compare the difference. Yeah. So yeah, I think that will be it for today. And next week we will be holding the community meeting in alternating time. Like it will be 8 a.m. PT. Yeah. So feel free to join if you can also make it. Then yeah. Okay. Yeah. Thank you so much everyone for joining the meeting. Yeah.
Thank you for hosting it.
Thanks.
Thanks.
See ya.
Thank you. Bye.
Thanks. Okay.